Okay? Multiplying complex numbers, we just got through talking about adding and subtracting. Now we're going to talk about the multiplication of complex numbers. So just to review again, complex numbers are of the form a plus bi, the real part plus the imaginary part. So in these problems, when we're multiplying, you're going to run into situations where you have I squared involved. Remember, anytime we have an I squared in our answer, we're going to substitute a -1 for I squared. So let's look at a couple of problems and see how it works. So where it says multiply these expressions, now we would know that it's multiplication because, as you can tell, you got parentheses right up against each other with nothing between, so we know that in algebra that means multiplication. So in this part, we're going to multiply the coefficients together. So -6 times 9, that would give me -54. But of course, I times I gives me I squared. Now, I just got through telling you, if you have an I squared, you're going to replace that with a -1. So -54 times -1, which is just going to make it a positive 54. So I squared definitely has an effect in your answer. Okay, let's look at this next one. -5i times -12i. -5 times -12 would be a positive 60, but I times I gives us I squared. Now we know we're going to replace the I squared with -1. So that's 60 times -1, which will give us -60. Pretty easy. All right. In these problems, we have -9i, which is just one little monomial expression there, times -4i minus 5i. So in this case, we're going to have to multiply with the distributive property. So -9i times -4, and then -i times -9i times -5i. So first, -9i times -4, that would give me positive 36, but I have one i, so 36i. Now, the next multiplication, -9i times -5i. -9 times -5, that will be positive 45. But then you have the I times I as well, so I squared. Okay, so let's work on that for just a second. 36i plus 45 times, we're going to replace I squared with a -1. So that's going to give me 36i minus 45. Now, as far as I'm concerned, that is correct the way we've got it right here. But if the problem is, if you're asked to write this in complex number form, the way that you normally write a complex number, we need to do that. So it's always a plus bi, if you remember that from the previous slide, a plus bi form, the real part. So in this case, that's -45 plus the imaginary part, so positive 36i. That's how you would write the correct way. All right, so let's look at this example below here. 4 plus 3i times 6 plus I. Two complex numbers were multiplying together, but it looks like a binomial times a binomial. And if you remember from earlier algebra courses, we used the FOIL method, first, outer, inner, last, to multiply these type expressions. And we're going to do that here just as well like we do it with normal binomial expressions. So 4 times 6, first times first. 4 times 6 is 24. Okay. Outer terms, 4 times I. So positive 4i. We're just going to stick those together. The two inside terms, that's 3i times 6. So that would be 18i. And then last, the last term times the last term, 3i times I. So that's going to be plus 3i squared. So as you can tell, I need to replace the I squared with a -1. Okay, so that actually is going to make that -3. So I have 24 minus 3. that would give me 24 minus 3 is 21. So my real part is 21. Then you have two terms with an I to combine, 4i plus 18i. So that's going to be plus 22i. So this is in complex number form. This is the product of these two complex numbers. All right. So let's just practice this skill just a little bit more. Another binomial expression times binomial. So we're going to do the FOIL method. So first would be negative 5 times 2, which is negative 10. Outers, negative 5 times negative 4i. That would give me positive 20i. Two negatives make a positive. The inner terms, negative 3i times 2 would be negative 6i. And last, negative 3i times negative 4i. That's going to be positive 12i squared. We see an I squared, we need to change that to a negative 1. So we have negative 10 plus 20i minus 6i. So I'm going to, instead of just writing the in 12 times negative 1, we know that's just going to make a negative 12. So combining your stuff here, your terms, you got your real parts, the negative 10 minus 12, so that's negative 22. And then the imaginary part, 20i minus 6i, that would give me positive 14i. Now my last example here is the same thing, but you could write down negative 3 minus 6i times negative 3 minus 6i. You could write it down and do the FOIL method. Or how many people remember how to square out a binomial? Now, in earlier algebra classes, we call this square, double, square. So what that means is you square the first term. So if I square negative 3, then we're going to double, so we're going to multiply by 2, the product of the two terms. So negative 3 and negative 6i, we're going to double that, so we'll multiply it by 2. And then you square the last term as well. So 6i squared. Square, multiply, and double, square. So let's see what we would end up with here. Negative 3 squared would give me a positive 9. In the middle, we have two negatives multiplied, so that gives me a positive. 2 times 3 is 6. Times 6 would be a positive 36i. Okay, and then 6i, this actually should be negative 6i squared, but this negative is going to go away when I square it anyway, so that's going to be plus 36i squared. So we know that the I squared becomes negative 1. So that's minus 36. So the real part, 9 minus 36, gives me negative 27 and plus 36i for the imaginary part of my complex number. Again, I could have achieved this answer by doing the FOIL method. I just used the shortcut to review it with you for other things